Humans just went to the moon and came back. I want to explain exactly what happened, what it actually meant, and why the numbers involved are harder to understand than they look. Artemis II launched April 1st, 2026. 4 people on board. 10 days later, April 10th, they splashed down in the Pacific Ocean off San Diego. That's the simple version, but the simple version leaves out almost everything important. Let me start with the distance, because I think people hear big numbers and don't feel them. The crew flew 695,081 miles total. That's the confirmed number from NASA. To me, that number doesn't mean much until you compare it. The moon is about 239,000 miles from Earth. So this crew didn't just go to the moon and come back. They went past it. They swung around it. They flew farther from Earth than any human being in all of recorded history. The previous record was Apollo 13. That was 1970. Those astronauts reached about 248,655 miles from Earth at their farthest point. For 56 years, no human had gone farther. The Artemis II crew broke that record on April 6, 2026. Confirmed. That's not a theory. That's a measured fact from NASA's tracking systems. I find that genuinely hard to process. We went 56 years without breaking that record. Then we broke it. Now here's where it gets more interesting. This was not a moon landing. I want to be clear about that because I've seen it described in ways that blur the line. The mission was a lunar flyby. The crew flew to the moon, swung around it at close distance, and came back. No one touched the surface. No one landed. The technical term is a free return trajectory, which basically means the spacecraft used the moon's gravity to slingshot back toward Earth. It's the same approach Apollo 13 used when it had to abort its landing. What I understand is that this was never meant to be a landing. It was a test, a full human test of everything that needs to work before NASA tries to actually land people on the moon again. The spacecraft is called Orion. The crew named their particular vehicle Integrity. NASA's official name is just Orion Crew Module, but crews get to name them. The way I understand it, that naming tradition goes back to Apollo. Apollo 13's lunar module was called Aquarius. It's not just sentiment. In an emergency, crew members need to communicate fast. Saying Integrity is faster than saying the Orion capsule. So there's a practical reason behind it. What was being tested inside Integrity? A few key things: life support systems, manual piloting, emergency procedures, communication systems at extreme distance. The life support part matters a lot. On a 10-day mission to the moon and back, the systems that recycle air, manage carbon dioxide, regulate temperature, and handle water have to work without failure. NASA hadn't sent humans this far in over 50 years. The Orion capsule is newer technology. It had been tested with no crew before. Artemis I, which launched in November 2022, was an uncrewed test of the same basic mission profile. But testing with no humans is not the same as testing with humans. People breathe differently. They move around. They generate heat. They use water. They need to sleep. The systems respond differently. There was a toilet issue on the mission. This is confirmed. I'm not going to pretend that's not relevant, because it is. On a 10-day mission in a small capsule 700,000 miles from Earth, the waste management system had a problem. The crew had to adapt. This is exactly the kind of real-world issue a test mission is supposed to find. It wasn't reported as a crisis. It was reported as something the crew handled and NASA noted for future missions. But to me, it's a reminder that space travel is not clean or simple, even with 60 years of experience behind it. Now let me explain what happened on April 6th. That was the day of the lunar flyby itself, and it produced two things I find remarkable. First, the far side images. The moon's far side never faces Earth. We've had satellites photograph it. We've sent probes past it. But no human being had looked at it directly since 1972. The Artemis II crew, flying around the moon at close distance, saw the far side with their own eyes. They photographed it. Those images are now publicly available through NASA's image gallery. The way I see it, that's a 53-year gap, over half a century, and it ended on April 6, 2026. Second, a solar eclipse. The crew photographed a solar eclipse from beyond the moon. This one needs a bit more explanation. From Earth, a solar eclipse happens when the moon passes between Earth and the sun, blocking the light. The crew was on the other side of the moon during this event, so they weren't seeing the kind of eclipse we see from Earth. They were seeing something rarer. From their position, the sun appeared to move behind the moon, the black disk of the moon in front of the bright ring of the sun. Only a human being in that exact location, at that exact time, could photograph that. The images are unlike anything taken before. I'll be honest, when I first read about that, I had to read it twice to understand why it was different from a regular eclipse photo. The angle changes everything. Now let me get into the crew, because I think it matters who these four people were and what their presence represented. Reed Wiseman was the mission commander, experienced astronaut. Victor Glover was the pilot. He made history on the SpaceX Crew Dragon mission in 2020 as the first black astronaut to live on the International Space Station for an extended stay. Christina Koch was a mission specialist. She holds the record for the longest single spaceflight by a woman, 328 days. And Jeremy Hansen was a Canadian astronaut, mission specialist, and the first Canadian to fly to the moon in any capacity. His presence made Artemis II an international mission, not just an American one. What I find interesting is the deliberate composition of this crew. NASA made choices here. These weren't random selections. This is confirmed through NASA's own statements. The agency wanted this crew to visibly represent a broader idea of who gets to go to space. You might be wondering about radio silence. On the far side of the moon, there's no line of sight back to Earth. No signal can get through. The crew lost contact with mission control for a period during the lunar flyby. That's expected and planned. But knowing it's expected doesn't make it simple. From mission control's perspective, they had 4 human beings, 250,000 miles away, and 0 contact for that window. The way I understand it, the crew was trained for this. The spacecraft was autonomous during that period, and the silence was relatively brief. But it's one of those details that makes the distance feel real in a way that numbers alone don't. Now write same for this. Let me now add the layer about what comes next, because I think this is where understanding Artemis II matters most. Artemis II was not the end goal. It was step 2 of a multi-mission plan. Artemis 1. November 2022. Uncrewed. Tested Orion and the Space Launch System rocket. Confirmed they work together. Artemis II. April 2026. Crewed. Tested life support, human piloting, communication at lunar distance, emergency readiness. Artemis III. Planned for 2027. The lunar lander gets tested in Earth orbit. This is important. The lander, built by SpaceX, it's called Starship HLS, needs to be tested separately before it carries humans to the moon's surface. Artemis IV. Currently planned for 2028. This is the actual moon landing. If Artemis III tests go well, Artemis IV puts humans on the lunar surface for the first time since December 1972. So for me, the key thing to understand is that Artemis II was proof that the hardware works with humans inside it. That's what it was for, not to land. To prove the path to landing is possible. There are two things I think are worth holding in your mind together. First, 695,081 miles, the longest human journey in history. Second, they still didn't land. They were still just testing. The moon is 239,000 miles away. The goal is the surface, and the surface is still 2 years away, at minimum. That's not a criticism. That's just the scale of what landing on the moon actually requires. It's easy to forget, because we did it in 1969, and it looks like something that should be straightforward by now. But the original Apollo program took most of the 1960s to get right, with the full resources of a space race driving it. Artemis has been slower. Funding gaps, technical delays. The lunar lander was redesigned. COVID slowed development. Artemis III was originally scheduled for 2025, then 2026, now 2027, and the landing keeps shifting too. What I take from all of this is not frustration, it's respect for the difficulty. Getting humans to the moon is genuinely hard. It was hard in 1969. It's still hard in 2026. One more detail I want to mention, because it came up in the post-flight press conference on April 16th, and I think it says something true. There was a zero-gravity indicator on board. Every crewed spacecraft has one. It's usually a small stuffed animal or toy that floats when the vehicle reaches weightlessness, giving the crew a visual signal that they're no longer under gravity. The Artemis II cruise indicator was designed by an 8-year-old. The name of the child hasn't been widely reported, but the indicator floated in front of cameras during the mission as the crew reached space. It floated 700,000 miles from Earth and back. I don't know why, but that detail made the whole thing feel more real to me than any of the numbers. So what do I actually understand now, having gone through all of this? Artemis II confirmed that humans can safely travel to the moon and back in the Orion spacecraft. The life support systems worked. The crew handled real problems. The distance record was broken. The far side of the moon was seen by human eyes for the first time in over 50 years, and the path to an actual moon landing in 2028 is now more credible than it was before April 1st, 2026. For me, the main thing is this: we didn't land, but we proved we can get there. And after 53 years, that is not nothing.